Hello YouTubers, welcome back my friends. Thank you for stopping by, really appreciate it. In this video I'd like to show you BBMPulser 5B as I just finished building it, and I would like to show you everything inside before I put glues and button everything up and make it so that you can see where wires are going. This is the circuit for this 2.4 Tesla automatic magnetic pulsar version 5B with a power control. You go to my website bbmpulser.org and search through the posts. You will be able to find this circuit. Also there's a page which calls electronic circuits. Just go there and you'll find one. Alright guys, so here is how the unit looks like. Very basic configuration. You have a power button here and you have a power adjustment. Also you have a pulse and a protection LED, thermal protection. Here is how it looks from the side. Here's the look from the top. Here's the back view of the unit. It has a coil attached to it. This is a 3-inch my classic coil with 1-inch air core, and that's the coil I use for BBMPulser 4, 5 and 6. I can get up to 5 Tesla with this coil. This coil is fully insulated inside and filled with resin, so nothing moves. It's a solid, very solid. So here is your 6 diodes for voltage multiplier. Seems like it has some voltage inside because I just got shocked by touching here. Down there's the capacitors. That's a part of the charging circuit for the capacitor bank. Those blue large capacitors are the capacitor bank. There's 2 of them in there. And by the way, you see here 3,300 microfarad, and these are 450 volts. So you guys, you can get away with 450 volts. Like in a circuit here, I'm asking for 500 volt capacitors, but the thing is, these 2 capacitors, they only charge to around 850 volts before they start discharging. So their combined voltage 450 times 4 plus 450 is going to be around 900 volts, and so that should be enough not to overcharge them. And so in this circuit I am using 450 volt 3,300 microfarad, and they're working just fine. I'll show you the power output from the Tesla meter in a second. And before that, I'm gonna show you the circuit board. So move the wires aside. I just got shocked again. Should have discharged the capacitor bank. Alright, so this component here is your thermal switch for inside. If inside of the unit is gonna get hot, for example, somebody's gonna block and cover everything with a pillow or something, and this exhaust fan won't be able to remove all the heat from inside, this thermal switch will trigger and will put the unit in a standby mode, preventing it from overheating inside internally. Also, there's a thermal switch on the coil right here. You can probably see it right there. That thermal switch also monitors temperature of this coil. Anytime it gets hot, it places the unit in a standby mode. And these 2 thermal switches are the safety feature for this unit. They're right here. This is one thermal switch, and right here is the second thermal switch that's built into the coil. Alright guys, so most of my components on this board are SMD, surface mount, tiny components. You can't even see them on the camera well. Like right there is one, right here, right here, right here, right here, right here. There's a bunch of very small components that I use to make it more compact. I'm still using some surface, some regular components that require drilling, so it's a combination of both. I just got shocked again. I really should have discharged this circuit. Alright guys, so let's go ahead and test it, and I'll show you the power output from this. Right now I have my Tesla meter configured to pick up the highest value. Here is the probe. The probe has north side where these letters are and the south side on the back. So you want to have the letters pointing up, and the tip should be almost to the center, like about there. Alright guys, let me turn on the unit. Sorry about that. So I'll go ahead and lower the power all the way down and turn on the unit, and let's see, 0.9. so I will go down as low as 0.979 Tesla, and if I increase to about middle, we're getting 1.3 Tesla. And if I increase more to about 2.4 Tesla all the way, then I will get, it takes about 10 seconds, 10-12 seconds. Here we go guys, 2.453 Tesla. Just like it says here, 2.4 Tesla, and right here, and right here you can adjust between 1.2 Tesla, which in reality we just tested. We can go down a little lower, we can go down to 0.98 Tesla, and we can increase all the way to 2.4 Tesla. 2.453 right here, Teslas. Alright guys, let me show you the bottom view of this unit. Usually I'll put the stickers on here. I just finished building it, so there is no stickers here yet. Inside look again. These capacitors, make sure you insulate them, because the negative of this capacitor is connected to the metal housing of this part of this capacitor, and if you somehow connect scratch this thin blue shielding, plastic shielding, and touch it to the housing of the unit, and housing is grounded, so right here is the ground strap right here, and here is another ground strap. So if you touch your metal casing from the capacitor to the body of the unit, you will blow the fuse. Also, you cannot touch them between each other, so two capacitors, you have to place separating plate in between them. Also, you have to place insulating plate underneath, and also your straps needs to be insulated so that they'll have some extra protection, extra insulation. And make sure you never poke anywhere. These capacitors, they should be shielded. They cannot be exposed or have bare metal. It's very important. Also, you want to put hot glue over all the exposed hot high voltage parts, exposed metal, seal everything. One more thing, guys, this is the last capacitor, I mean last diode, which is this diode here, before it enters your capacitor bank. What you want to add a resistor here. So basically this part right here, it's a resistor. This is one wire comes in, and this is the wire that comes out, and it goes to the capacitor bank. Right here, basically I cut it here, and I inserted a resistor right in here. So what this resistor does, it allows to remove the spike. Anytime you make a pulse, especially when you charge the capacitors all the way to the maximum and you make a pulse, this diode receives a lot of current, and sometimes these circuits, when they're 220 circuits, they would blow. So you need to make sure you add this in order to prevent these diodes from blowing. Alright guys, if you have any questions, let me know. Subscribe, like, and I'll see you in the next video.